Questions on the homework? Questions on any of the homework assignments? Questions over any of the homework assignments so far? So far we've had 4 because we had 1 over 4-1, 4-2, 4-3-1, and 4-3-2. So 4 assignments thus far. Questions on the homework?
Question 18.
Okay. 4-3-2. 4-3-2. So 4-3-2, guys, let's focus up here. We're going to go over this homework problem using synthetic division. We want to divide this here. So with synthetic division, the first thing we do is solve for x with our x plus 5. So we would subtract 5 from both sides, telling us x is -5. So -5 will go in the cubby. Numbers going across the top would be 1 for x to the 4th, 4 for x cubed, 0 for x squared, 16 for x, and -35. We had to put the 0 in because anytime we have a missing term, we have to fill it in with 0. One way that we can know we have the correct number of terms, correct numbers of numbers going across the top, is it's going to be 1 more than whatever the degree is. Since the degree is 4, we need 5 terms because we're going to have the 4th power, 3rd, 2nd, 1st, and then 0. So we have to add the 0 back in to know the correct number, and we do have 1, 2, 3, 4, 5. So they're all there. Our first step is to multiply. -5 times 1 is -5. We add straight down. 4 plus -5 would be -1. -5 times -1 is +5. 0 plus 5 is 5. Let's focus up here. -5 times 5 is -25. 16 plus -25 is -9. -5 times -9 is +45. And -35 plus 45 gives us +10. We put a box around the last one because it is our remainder. The -9 will be our term without a variable. 5 will be the term with x. -1 will be the term with x squared. And 1 will be the term with x cubed. So our final answer is x cubed minus x squared plus 5x minus 9 plus 10 divided by our x plus 5. And that would be our final answer. Now, as a side note, the degree of what we have as our final answer is always going to be, if we take, or we could find it by taking the degree of what we're starting with, in this case is 4, and subtracting from it the degree of what we're dividing by, which is 1, and 4 minus 1 is 3. So the degree of our solution should be a degree 3. Well, the biggest exponent for this is 3, so that does hold true. Questions on this here? Now, our goal in this chapter is to solve these higher degree polynomial functions. To find the solutions for x to the 4th plus 4x cubed plus 16x minus 35 for polynomials like these here. Now, up to this point, we have not covered a single way to actually solve them. We have found methods, we've gone over methods that will help us solve, but none in particular. Because the only 2 methods that are guaranteed to work for any higher degree polynomial function is the quadratic formula and completing the square. But quadratic formula and completing the square mainly work with quadratics. So our main goal, or part of our main goal, is if I can reduce the degree from a degree 4, fourth degree polynomial, down to a degree 2, then we can use the quadratic formula or completing the square or factoring to solve it. That's the big goal. And there's different ways we can get to it. Now, as we see here, if I know one of the factors of this, I can reduce the degree from 4 to 3. If we knew another, we could reduce it from 3 to 2, and we can solve from there. So that's one thing that's helpful. Another that's helpful is factoring. Factoring does work with these higher degree polynomial functions. Now there's a few that we're going to look at. We'll look at these here. And these here actually end up being quadratics for the most part. And we're going to also look at grouping and some indifference of perfect cubes. Now whenever we factor or we look at these higher degree polynomial functions, the first thing we should be looking for is a greatest common factor. Greatest common factors are always helpful when solving or factoring. Because if we look at a, x to the third minus 4x squared minus 5x, is there a number or term in common with all three? Is there something that x cubed, 4x squared, and 5x all have in common? Because we don't have a number, but we do have a variable x. Yes. Yes. Because at this point, we're very comfortable with a greatest common factor being a number. But it can also be a variable. It could also be a variable and a number. But here, we have a greatest common factor of x. And if we factor that x out of x to the third, we're left with x squared. If we factor it out of negative 4x squared, negative 4x. And if we factored out a negative 5x, we're left with negative 5. So we have x times our x squared minus 4x minus 5. Now, x squared minus 4x minus 5, we can factor it. We know how to factor those because we have our two sets of parentheses with 3 spaces. Now we look for the sign. If the third term is positive, the signs are the same. It matches the sign of the middle term. If the third term is negative, the signs are opposite. So since it's negative, one of them is going to be positive, the other is negative. Now we're going to look at the factors of the first and third term. Factors of x squared would be x and x, because that's the only set of factors for x squared. Factors of 5 are 1 and 5, yes? Are there any others? No? So we can just plug these in. And lastly, we can check to make sure we do have the correct factors. X times negative 5 is negative 5x. 1 times x is plus x, giving us negative 4x. Is that the middle term we wanted? Yeah. So x cubed minus 4x squared minus 5x factors to x times x plus 1 times x minus 5. Questions on this here? Let's look at the next one. 3y to the 5th minus 48y cubed. Again, the first thing I would look for is the greatest common factor. Is there one? Which is? Okay. Because we'd have 3, and we'd also have y to the 3. Because 3 is divisible, 48 and 3 are both divisible by 3. We can divide both of those by 3. Now for our variables, factoring out a greatest common factor, is we look for whichever variable has the smallest exponent. Because the first one has 5, the second one has 3. So the most I can remove from either one is 3. Because I can remove 3 from the first, which is going to leave me with 2. But I can't take more than 3 away from the second, because it only has 3. So that takes care of the variables. But our numbers are 3 divided by 3 is 1, which just we could say is 5, or y squared. 48 divided by 3 is 16. Because factoring those out, we can do that in a calculator. We can divide 48 by 3 and see what we get. And we get 16. Is y squared minus 16 factorable? We have 2 terms being subtracted, yes. And the only way we've learned to factor something if we have 2 terms being subtracted is difference of perfect squares. Is y squared a perfect square? What times itself is y squared? 1. Y squared is a perfect square. Is 16 a perfect square? 4 times 4. So it's a difference of perfect squares. It's our a plus b and a minus b. So we'll still have our 3y squared. We'll have plus and minus. And our term that squares to give us y squared would be y, so we'd have y and y. And our number squared that gives us 16 is 4 and 4. So we have y plus 4 and y minus 4. And the way we got that so quickly is our a squared minus b squared is a plus b times a minus b, where a and b are the numbers that squared to give us our squared term. In this case here, a is y and b is 4. Questions on this here? Questions on any of this so far? Yes. Yes, thank you. Yes. That was just for some reason, rewrote it as a 2 instead of a 3. Questions on any of this so far? Now, as we notice with these here, for the most part, it's not too different than what we did in the last chapter for factoring. We're just adding variables as part of the greatest common factor. Because if we look at C, is there a greatest common factor between 5z to the 4th, 30z cubed, and 45z squared? So we do have 5. 5 goes into 5, 30, and 45. And we also have a z to the second. 4th, 3rd, 2nd, so we can remove 2 z's from all 3 and divide each one by 5. Well, our 5 factors out of 5z completely, and if we remove 2 z's from z to the 4th, we're left with z squared plus 6z, because 30 divided by 5 is 6, and if we remove 2 z's away from 3, we're left with 1. And 45 divided by 5 is 9, and z factors out completely. So we're left with 5z squared times z squared plus 6z plus 9.
Merry Christmas from me.
Oh, thank you. Now the question is this factored completely? It is not. Now, one of the giveaways that it's not factored completely is inside our parentheses, our z squared plus 6z plus 9. The degree is 2. So there's a good chance it will factor. Now, I will show you this here, because there's one way to check to see if it factors into something nicely, and that is b squared minus 4ac. And this works for all quadratics, because if we plug this in and we get a integer, well, we're actually going to get a whole number either 0, 1, 2, 3, we don't get a decimal, it's going to tell us that it factors completely, or does factor. Now this should look familiar because the quadratic formula, this is the second half of it. And really the reason this works is if I'm finding the solutions, and this gives me a actual number, not a decimal, it means the answers are going to be rational. And if it doesn't come up as imaginary, it means also the answers are rational. If the answers are rational, it means it can factor. So here, if we plug this in, it'd be 6 squared minus 4 times 1 times 9. Second square root. 6 squared minus 4 times 1 times 9. Now, when we did the quadratic formula, we normally didn't plug it in all at once because it could either A, turn out as a decimal, or B, what's inside there could be negative. And the 30xs will not take the square root of a negative, correct? Am I actually solving anything at this point? No, I'm just wanting to see if it factors. I got a 0, I got a natural number. So it does factor. Because if it turned out to be negative inside there, 30xs would have thrown it out, said invalid domain. And that just tells me it doesn't factor. So all that's telling us is, does this factor? Yes. Two sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and match the sign of the middle term. Plus and plus. Factors of z squared are z and z. Now, unlike the first one, factors of 9, 1 and 9, or 3 and 3. Which one do we want to use? 3 and 3. And we can check this here just to make sure. Z times 3 is 3z. 3 times z is 3z, giving us 6z. Positive 6z. Is that the middle term we wanted? Yes. So that's our answer. Now, if we wanted to, we could simplify it a little bit. Because our z plus 3 and z plus 3 are the same. So I could say that it's 5z squared times z plus 3 squared. Because whenever we have a term multiplied by itself, it's the same as squaring it. Either one of these here, you don't have to have both. You just need one. So if you left it as 5z squared times z plus 3 times z plus 3, that is the correct answer. Questions on these here? Questions on anything we've done so far? Let's do one more. We want to factor x cubed plus 10x squared plus 24x. Is there a greatest common factor between these 3 terms? And it is. Because we would have an x. Now, there's not going to be a number because of the x cubed. Because the number in front of x cubed is 1, and factoring a 1 out from everything does nothing. Because if we divided 1 by x to the third, we still have x to the third. 10 divided by 1 is still 10, and 24 divided by 1 is still 24. It doesn't do anything. Whenever one of the terms does not have a number in front of it, most likely we're not going to be able to factor a number out. But x cubed, x squared, and x, all of them do have an x, so we can factor it out, leaving us with x squared plus 10x plus 24. We could try plugging this in to the calculator, see? Second square root, 10 squared minus 4 times 1 times 24 gives us 2. So it is factorable. Third term is positive, so the signs are the same and match the sign of the middle term. And plus and plus. The only factors of x squared are x and x. Fortunately, we can't say the same thing for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And that is it. Which set of factors do we want to try first? 4 and 6. And if we multiply these together, x times 6 is 6x. 4 times x is positive 4x, which gives us a positive 10x, which is the middle term we wanted, and we get this here. Questions on any of this so far? Are you ready for the next one? We have these here. And really, these are more of just what we've been doing. Let's look at two more and then we'll move on. Or at least one more, because that next one's no different. So if we look at B, is there a greatest common factor with 5y to the fourth? Because 5 will go into both 5 and 125. Y to the 6 and y to the fourth, we can remove 4 from both of them. If we factor 5y to the fourth from 5y to the 6, we're left with y squared. 125 divided by 5 is 25. Y squared minus 25 is a difference of perfect squares. Because we have two terms being subtracted, well, y squared is y times y. So we'll have y and y. And 5 times 5 is 25. And then we'll have the plus and minus. Questions on any of this here? I feel at least decently comfortable with these here. Yes. So for the most part, these here aren't any different than what we've done or factored before. It's just now the greatest common factor can be a number and a variable. Once we factor that out, we can go from there. Do we need to see another example of one of these here? Now, here is the first new set of factoring we're going to look at. Now, you don't have to write the example, but we do have these two setups here. And there is an interesting pattern with how these work. If we look at the sum of two cubes, specifically I'm going to look at the signs first. Since we're adding two, it's the sum. The signs are positive, negative, positive. Same, opposite, always end on a positive note. The difference of two cubes, we're subtracting. The first sign's negative, the second sign's positive, the third sign's positive. Same, opposite, always end on a positive note. A cubed, B cubed. In the first set of parentheses, we have A and B in both cases. So whatever times itself 3 times, that gives us the first term, A, and the second term, B. We have A and B in both cases. If we look at the bigger set of parentheses, A is squared, A is to the first, and then lastly, A is to the 0, where we just don't list it because it's a multiplication of 1. B is going the opposite direction. A is going 2, 1, 0. Going down, it's decreasing. B is going the other way. With A squared, really, we have B to the 0. B to the first, B squared. It's going up. A is going down. We have this pattern here. And this will make a little more sense when we get into it, when we start doing these. but that is the set pattern there. So, since it's a sum, the signs will be the same. Since it's plus, plus. Opposite. Since it was plus, it is now minus. And we always ended on a positive note, plus. So if we look at the difference, same to the first sign is minus. Opposite, plus. Always ended on a positive note. And the powers of a, so a cubed, b, a squared, a, no b, b squared. Now, let's look at this here. We're going to look at the first one with this here. Factoring the sum or difference of perfect cubes. So we have this here, x cubed minus 125. To determine if this is a sum or difference of perfect cubes, we're going to take the cubed root of both terms. So we're going to take the cubed root of x to the third and the cubed root of 125. Well, can we take the cubed root of x to the third? Yes, it's just x. Cubed root of 125. If we don't know that off the top of our head, that is fine. We can type it into the calculator. 3 second caret, because it's our x radical, because we need to take the cubed root, and we can type in 125, and it is 5. So what that tells us is that this is a difference of perfect cubes, because x cubed is a perfect cube, 125 is a perfect cube. Questions on this so far? We good with this so far? Now, when factoring a difference or sum of perfect cubes, we started off with our, what I call the tractor trailer. Because the first set of parentheses is going to have 3 spaces, the other will have 5. Because we'll have 3 terms and 2 signs. We ready for the next part? So the signs is what we're going to do next. The signs are the same, opposite, always end on a positive note. So since we're talking about a difference, same would be minus. Opposite, plus. Always end on a positive note, plus. So for this one here, we have minus, plus, plus. Same, opposite, always end on a positive note. Questions on this so far? Our A, in this case, is going to be x. It went first. So in our first spot in the small set of parentheses is going to be x. In the bigger one, we have the first term squared, first term to the first power, and in the last one, it would be x to the 0, but anything to the 0 power is 1. With our multiplication of 1, we don't have to write it in. Questions on how we've plugged in the first set of terms? B. It is the fourth. Is 5. So in our other space, in the first one, we will have 5. With our x squared, our a squared, we will not have a b, a 5 term. In the middle one, we'll have 5 to the first, and the last one will have 5 squared. Questions on this here? Questions on anything we've done so far? Are you ready for the last step? Last step is to simplify. In our first set of parentheses, we'll just have x minus 5. In the second one, our x squared is just x squared. Our x times x would be x squared. Plus, x times 5 is 5x. Plus 5 squared is 25. And x cubed minus 125 factors as x minus 5 times x squared plus 5x plus 25. And that's as simplified as it gets. The quadratic, or second degree polynomial expression that comes out of a sum or difference of perfect cubes will always have complex solutions. It will not be factorable. Questions on this here? Are you ready for the next one? So the first thing we can do before factoring this is seeing if it is a sum or difference of perfect cubes. Now the cubed root of x to the third is x. Because our cubed root and third power will cancel each other out, giving us just x. Cubed root of 64. 3 second cubed root 64 is 4. One thing to make sure is when you take the cubed root or plug it into the calculator, that 3 should get a little bit smaller from when you type it in originally. Because I'll type in a normal 3 here. As we can see here, the 3 and the 1 with the cubed root, it got a little bit smaller. If it stays the same, that's just saying you're taking 3 times the square root. And if we typed it in here, we should get 24. Because square root of 64 is 8. 8 times 3 is 24. So do make sure to pay attention to that 3 when you take the cubed root. So 3 second above the one we do for square root is x root. So it's taking the x root of whatever the number was in front of it. Now you can do second x root. It'll leave a space or replace it with a and s. It'll take the previous answer. You just have to replace that with a 3. Now part of the reason we did this is to determine if this is a sum or difference of perfect cubes. And we see that this is. Cubed root of x to the third is x. Cubed root of 64 is 4. Now at this point here, we're going to set the tractor trailer up. Signs, same, opposite, always end on a positive note. Starting sign was negative, so same would be negative. Yes, opposite of a negative is a positive. Yes, positive, negative, positive. Yes, if that works, keep with it. Because with either one, there's always going to be 2 positives and 1 negative. It's really the first 2 switch places. Because we have that or same, opposite, always end on a positive note. Both work. Now, questions on this here before we plug in sign or our other expressions. X is our A, it's our first term. And in the first set of parentheses, we'll just have x. In the bigger one, in the first spot, we're going to have our a squared. We have x squared. In the middle, we're going to have x to the first. And the last one, we don't put anything in there. B is our 4. Now, I'm putting the a and b really just referring back to the general forms. In this case, it's our a minus b times a squared plus ab plus b squared. Now, the bigger one with our 4, there's nothing with our x squared. Our middle would be 4 to the first. And our last one is 4 squared. Questions on this here? Questions on how we did this here? And the last step is to simplify. In our first set of parentheses, on most of these here, it's just going to be the same. Here it's just x minus 4. Second one, we have x squared, which is just x squared. And for the most part, it'll simplify down to this here. The only time it won't is if we have something more than just x. So if we had 2x or 3x, we had two terms in there. Middle term, 4 times x is 4x, and 4 squared is 16. So x minus 4 times x squared plus 4x plus 16 is the final answer. Questions on these here?
What if we do if the exponent is
Like this here? So, is s to the 5th a perfect cube? Can we take the cubed root of s to the 5th? No. Can we take the cubed root of s squared? No. So even with these here, we can still look for a greatest common factor. Because if we look at s to the 5th and x squared, is there a greatest common factor between these two terms? Well, s squared. Because I can take an s squared out of s to the 5th, which leaves us with s cubed. And s squared factors out completely from s squared. Is there a greatest common factor between 16 and 54? So 54 does not divide by 16, unfortunately. But we do know for sure that 2 does work, yes? 16 divided by 2 is 8. 54 divided by 2 is 27. So we can do 2 first and then check and see if there's another greatest common factor. Well, the only other factors of 8 are 2 and 4. Any other questions on how we got to this point here? Now we will have some that are sum or difference of perfect cubed. We just have to factor something out first. Now at this point here, we can check to see if they are perfect cubes. And the cubed root of 27 is 3. Cubed root of 8 is 2. Cubed root of s to the 3rd is s. Now we have this set up here. Our signs are going to be the same. Opposite, always end on a positive note, so plus, minus, plus. Now at this point here, we're going to fill the first term in. So in our first set of parentheses, we're just going to have 2s. In the bigger one, we'll have our first term, 2s being squared, and then 2s to the first. And the last one, we don't write it, but it would be 2s to the 0, which reduces to 1. In the other spot, we would have 3. In our squared term, we'd have 3 to the 0. We don't have to write that. In the middle, it'd be 3 to the first. And the last one, we would have 3 squared. So this here reduces to 2s squared times 2s plus 3. And then the last one, we do have to actually do some calculations. 2s squared. 2 squared is 4. And s squared is s squared. Since there's not a sign between the 2 and s, we're just multiplying it by itself. So 2s times 2s gives us 4s squared. Minus 2s times 3. 3 times 2 is 6. And we have our s And lastly, 3 squared is plus 9. So, for this one here, we had to factor out a greatest common factor before we could factor. We will pick this up tomorrow.